Hey, hi guys, welcome back to 360DigiTMG's domain analytics program. As you guys know, we are discussing the banking and insurance analytics. So how the machine learning algorithms, the deep learning algorithms, or you can also call it as the AI. So whatever, just so banking and insurance analytics that we've been discussing, what exactly the deep learning algorithm and machine learning, how we will be applying the deep learning or machine learning algorithm or AI when it comes to banking and insurance analytics applications, all those things we have discussed. If we are following various algorithms we have taken the supervised algorithm, we have taken the unsupervised algorithm. In unsupervised, we have taken the K-means algorithm, and we have tried, we have built a machine learning model clustering. In unsupervised, so we have taken K-means and we have done the clustering. And in supervised, various algorithms we have taken like KNN. Using the KNN, we have done the classification. And we have gone with the decision tree algorithm and multiple linear regression. So all these use cases we have seen till now. In today's session, we will be discussing about neural networks. So how we will be implementing the neural networks, also we can call it as a deep learning. So what exactly the difference between the neural networks, machine learning and AI, that is also we'll discuss very briefly. And we'll try to implement one use case when it comes to banking and insurance analytics, and we'll try how we will be building the neural networks from the scratch, how we will be designing that whole network. So those are all things we'll see in this today's session. So without wasting any time, let's get into the session. Before that, we'll see what is the agenda of this session today. What are the agendas we have? What are the topics we'll be covering? Neural networks, primer. Very first thing, what exactly the neural network is? So how it is different from the, is it different from the machine learning or not? So if it is not, in that case, how we can differentiate in between the machine learning and deep learning? And what are the factors that includes when it comes to machine learning and deep learning? And which one is preferable, whether it is machine learning or deep learning, that is also we'll discuss. And perceptron, we have two, perceptron algorithm will be having, and we will be having a multi-layer perceptron will be having. What is the difference between those? What are the activation functions? What is the error surface? Gradient descent algorithm in order to decrease the error rate when it comes to anything, whether it is multiple linear regression or it is a neural network. So we will be using those, and based on that, we will be going with the accuracy rate. So what exactly that gradient descent algorithm? So that is also we'll try to discuss. So before getting into that, what exactly the deep learning is? Is it very different from the machine learning? No. So in machine learning only, deep learning is small part of machine learning. And this machine learning is part of data science. So data science is part of AI. So whatever the algorithms that you are doing, and at the end of the day, you will be end up building the one product. That product will be calling it as AI-based products, artificial intelligence. So in that, we will be using the machine learning as well as deep learning based on our requirement. If you are going with some complex models that that require so much feature engineering, like OCR, we will be having character recognition. Handwritten characters will be having which character it is, which character it belongs to. For that recognition, we will be using the deep learning. We can use machine learning as well, but deep learning will be doing the feature engineering by itself. most of the neural networks will be doing the feature engineering by itself. That is, we don't need to do much, and we just need to do a very small part as a programmer. In that case, itself, it will be doing the feature engineering and all. In that case, it results in a good accuracy. So in that case, we will be using the machine learning, deep learning part, and the rest of the time we'll be using the machine learning. So what is the advantages we'll be having when it comes to machine learning, and what are the disadvantages we'll be having when it comes to machine learning? I mean, not disadvantage, what are the limitations we'll be having when it comes to machine learning? And in what exactly deep learning, how it will be helping, deep learning will be helping to drawbacks, whatever the drawbacks will be having when it comes to machine learning, how we will be overcoming that. That is also we'll try to explore. So normally machine learning compared to the machine learning models, deep learning models, most of the time models will be giving the high accuracy compared to the machine learning model. Most of the time it will be giving the high accuracy. In that case, is that mean machine learning models we can simply overthrow and we can use only deep learning models? No. So it's been very long time. It's been quite a time since deep learning algorithms are extensively used. That doesn't mean we have overthrown machine learning models. So where exactly we will be using the machine learning in that case? Let's say banking. Let's say we are building one model that is for banks, since we are dealing with the banking analytics, banking and insurance analytics. So we'll take one use case when it comes to banking. Let's say I'm building one machine learning model that is predicts whether that particular person gonna default the loan or he's gonna pay back to defaulter or not. So the output is yes or no. Yes means defaulter, no means is not a defaulter. So we have used various features like X1. We can based on the bank, several features they will be using. Some will be using like tens of features, some will be using hundreds of features. So I'll be simply mentioning like a few just to explain. X1, X2, X3, something like that will be having like salary, age, whether married or not, marital status, and collateral, do we have any collateral or not, and he has a job or not. If you have a job, since how many years you are working, still working or not, whether the job that you are having, is it a skilled job or not. So like that, we have tons of features. Based on those features, we will be deciding whether we have to, is that person going to be going to default the loan or not. If you know this, whether that particular person will default or not, in that case, we will decide whether we have to approve the loan or not. Approve that loan or not. If you know that if he is going to default, in that case, why do you take risk? Banking, the whole banking, it depends on these loans only. Most of the income they are generating, it is based on the income loan only. If people who are taking the loan, if they are not paying back, and if they are being a defaulter, in that case it will be not a good sign for the bank. So what it will do, it will try to decrease the number of defaulters. That is the reason we have come up with this model. Let's say we have built a model and then we have deployed using the neural networks. So whenever we are talking about neural networks, the model we will be building, it is a black box. It is a black box. That is, what does that mean? We know what are the inputs that we are giving. So we will be knowing what will be the output, but what exactly happening inside that algorithm, whether it is multi-layer perceptron or the single layer perceptron, what exactly happens inside that algorithm, we don't have any idea what kind of features it is. Let's say this example will be having it. So in order to decide whether that particular person going to default or not, whether it is defaulting, what are the features it is considering, and which base it is saying that that particular person going to default. if it's going to not going to default, which features, what is the logic behind it, and which base it is talking about the default, whether individual going to default or not. So that we won't be able to understand. We don't have any idea. So this internal, that is the reason we will be calling it as unexplainable AI. Unexplainable AI. So presently, whatever the algorithm, deep learning algorithms will be having, it is all based on the unexplained AI. So whatever the internal process, what are the features it is considering, that we won't be able to explain. So if you are building the model based on the ANN, artificial neural networks, and you are deployed the model. Let's say one customer asks you, you say he applied for the loan. He applied for the loan, and whatever the features on whichever the feature you build the model, so the same feature will be giving as an input once it is deployed. So let's say the deep learning algorithm said that whoever applied, he will be defaulting. He is a possible defaulter. In that case, don't give a loan. This is the output that we have got. So if person asks, can you say that that one machine told not to give a loan? They will definitely ask, you have rejected my loan, and which base you have rejected? What are the reason behind it? Definitely everybody want to know if something got rejected, what is the reason behind it? So if you say answer saying that machine learning, that AI said, final prediction we have got that you might be become a defaulter. In that case, we won't be giving you a loan. We are not approving the loan. Is it a good answer? No, it is not a good answer. He won't be liking that answer at all. So what we have to do here, you might be getting the deep learning you have used, and if you are using the machine learning, let's say it is getting 87 accuracy, 87% accuracy, and deep learning is given 95% accuracy. Still, people won't be satisfied with that because they need explanation. What is the reason? What is the reason behind it? Why did you reject my loan? Definitely they will be asking. So what we need, explainable model we need. Explainable model we need. So that we can do using the machine learning, especially decision tree. So model is what? Whether that particular person is going to default the loan or not. So this is our model, right? So decision tree will tell you if decision tree is saying that that particular person is going to default, and which base it is saying he is going to default, he'll list down all the features, all the conditions. So these are the reasons. That is the reason you might default. These are the criteria you are not fulfilling. Maybe that is the reason you might default. So next time when you are applying, make sure you are fulfilling these features. Something like that. Decision tree will tell. Decision tree, what are the features it is considering? It is simply, what is the feature it is considering? It will display. Decision tree, the whole feature it is considering in order to tell whether that particular person is going to default or not. So that explainability we lack when it comes to deep learning algorithm. When it comes to machine learning algorithm, we can explain. So whatever the model, last session we have seen, right? The decision tree algorithm. Decision tree algorithm. What are the features it is considering to tell whether we have to give a loan or not? What are the features it is considering? Each and everything it will be noted down. You can simply give that list to that particular customer whoever got rejected. These are the criteria you are not fulfilling. So we are rejecting your loan. So even though machine learning are giving less accuracy, but the explainability that we have in machine learning, we don't have in the AI or the deep learning part. So that is the reason we still prefer machine learning model. It's not like always we'll be preferring. Sometimes explainability doesn't matter. I want just accuracy, good accuracy I want. So in that case, we can simply go with the deep learning model, but sometimes we need explainability over the accuracy. In that case, we'll be going with machine learning model. Among that explainability, decision tree is the best model. Any number of models will be coming. It will be, you can see every now and then there are so many models will be coming into the market, but decision tree, the explainability decision tree will be providing that much explainability you won't be having in any model. So it is the one of the reason, even though AI is giving the good result, we need explainability. That is the reason we'll be preferring machine learning model over AI. So yeah, so that is the difference when it comes to AI, machine learning and deep learning, and which one we have to prefer. Even though it is giving the accuracy, AI or the deep learning, we still, why we are preferring that, the machine learning model. So now we'll see how the deep learnings, the artificial neural network will be working. Yeah, we'll understand what is the artificial neural network and how, from where they have taken that, and how we will be doing the, how the whole artificial neural network will be working, that we will see now. So artificial neural network, nothing but this is a mimic of human brain. So normally in human brain also we'll be having the neurons. So you can see here, so this is a neuron. In our brain we'll be having neurons. These are the neurons. So you can see these we will be calling it as dendrites. These dendrites will be taking the signals from various parts of the body to the brain. So whatever the information that is taken into this cell body, this neural, the whole processing will be done in whatever the information it is. Dendrites are collecting. Based on that, it will be taking some decisions. Processing it will be taking, and then it will be taking the action. Let's say how this neuron will be working. Let's say you you inserted your hand in just to check what is the temperature of one bucket water. In that case, if it is too much, in that case, what you will be doing? Immediately you will be taking out your hand from the bucket. In that case, what happens? When you are inserting your hands into bucket, that hot water bucket, so whatever the temperature sensors will be having, similar to that, hand will be collecting the all information and it will send that information to the brain, and what brain do, it will process what action we have to take it. In that case, if it is too hot, in that case, what brain says? Immediately take out that hand from that particular bucket because it is too hot. So what happening here? All the information it will be collecting. What kind of information? How hot it is. Once it is collected, it will reach to the brain neurons, and there it will be taking the process. And once it is done, immediately it will be taking the action. So this is how the neuron works. The neuron will be working. Similar to that, when it comes to artificial neural network, so we will be having inputs. So inputs will be taking the various inputs, and then we'll be having the hidden layer. It is similar to the cell body. So all the processing will be happening in the neural hidden layer, and then we will be doing the output. Similar to what we have in comes to human brain, exactly similar we will be having when it comes to artificial neural networks. That is the reason neural, these are the human neurons will be called as, and similar to that we'll be having artificial neural networks. Same human body, whatever the brain neurons will be having, that is only will be mimicking. We'll try to create a copy of similar copy. So that is the reason we'll be calling it as artificial neural networks. So what are the various artificial neural networks that we have? So neural networks is a machine learning model inspired by the networks of biological neurons found in our brain. It is inspired by, I mean, we are trying to create one copy of the same human brain neurons. So it is inspired by that. That is the reason we'll be calling it as artificial neural networks. What are the types of neural networks we'll be having here? Artificial neural networks, or we will be having just single layer perceptron. In that we'll be having multiple layer perceptron as well. Convolutional neural networks will be having when it comes to the images. Mostly when it comes to images, we'll be dealing with convolutional neural network, and then we have a recurrent neural network. So like that, we have three types of neural networks. So fun fact, the human brain is made up of about 85 billion neurons. So among those, very less amount of neurons we will be using, and the rest it will be staying idle. So there is no one who who used 100% of the brain until now. So very small amount, small percentage of brain we will be using, and the rest will be added. So about 85 billions of neurons we will be having when it comes to human brain. For instance, I mean, what are the other animals will be having? How much neurons will be having? When you have a large amount of neurons, in that case, definitely that particular animal or anything, creature, definitely it will think smart. So when you have this much neurons, in that case, definitely evolution and the kind of thinking will be having much advanced compared to the animal. So here you can see cats has roughly 1 billion neurons. So cats has, so roughly we have 1 billion neurons, and mouse has about 75 million. And cockroaches have only about 1 million neurons. In contrast, many ANN contain fewer neurons, like several hundred. So whatever the model that we are building, so we will be talking about it. You might have gone through so many articles that artificial intelligence are this will be taking over the humans. So it is not going to happen, because whatever the products that we are working on till now, we are not even using the few thousand. We are not using few thousand neurons. So, and human has over 85 billion neurons. So it is not going to happen anytime soon. So yeah, it will take like hundreds of years to reach that particular technology. So these are the various animals and the kind of number of neurons they will be having. So how perceptron algorithm will be working? On which base? How it will be deciding? How it will be classifying? If it is regression, in that case, how it will be doing? The whole process we'll try to understand. So perceptron algorithm, when it comes to single layer perceptron, if you are talking about, if it is, see, just one output will be having, in that we'll be having whether it is yes or no. Just one neuron will be having as an output. Here we'll be getting one binary classification, 1 or 0, that is the binary classification, yes or no. So whatever the model that we have built for whether that particular person going to default or not, in that case also we have just single output. At a time it will be giving just one output. The perceptron algorithm, a 2-class binary classification machine learning algorithm. The building blocks of the neural networks are what are the neurons will be having, and weights and activation functions. So here we'll be having weights. But whatever the input values you are taking, for each and every input values are the features. We will be having one weight, and then whatever the weights we'll be having here, we'll be having summation, and then we'll be having activation function. Once the activation function is activated, then only the output will be, we can see the output, otherwise we won't be getting any output. So what are the main components we'll be having when it comes to artificial neural networks? It is neurons, weights, and the activation function. It has a single node, the neuron that takes row of data as an input and predicts the class label. Neuron have weighted input. So whatever the input that we'll be having, let's say these are our neurons. So these are the input, and we have one bias. So we will be having bias output always. so that the whole neural network won't collapse. So we will be maintaining some value in order to avoid that, and then we'll be having one output. So here we'll be having summation. If that summation reaches the maximum, in that case, this activation function will be activated, and then you'll be getting the output. So here, let's say we are taking the x1, x2, x4, and x5. So these are the features I'm considering, are the inputs I'm giving. So each and every input having a weight, W1, W2, W3, W4, and W5. With respect to each and every input, we will be having the weights. So how the activation function will be activated? So let's say weights W1, and if you are using the X1 as the input, plus W2, X2, plus W3, X3, plus W4, X4, plus B if it is greater than 0. If it is greater than 0, in that case, activation function will be activated, and it will be giving 1 as an output. If it is not greater than 0, in that case, it will be giving just 0 as an output. So this is achieved by calculating the weighted sum of the inputs and the bias set to 1. So what is the weighted sum here? W1 x1 plus W2 x2 plus W3 x3 plus W4 x4. If we are having any number of, how many number of inputs you will be having, that many weights you will be having. Plus bias. So if it is greater than 0, in that case, that activation function will be activated, and the output you will be getting. If the activation function is above 0.0, the model will put 1, otherwise it will be putting as a 0. So this is how the artificial neural network or single layer perceptron will be working. Activation function, it is weight into input plus bias. Based on that only, we will be having that activation function. So the predict 1 if the activation function is greater than 0.0, and it predicts activation function is equal to 0 if it is equal to 0 and less than equal to 0. As the inputs are multiplied by the model coefficient, as in case of linear regression. Normally, when it comes to linear regression, how the output function works, guys? Output, it is a prediction we will be doing, that is x1, that is coefficient we'll be having. For that, we'll be having beta naught as a coefficient, beta 1, beta 2, x2. So these are what? x1, x2, x3, beta 3, x3, plus beta 4, x4. Like that, I have taken the 4 outputs. 4 inputs I have taken. These are the features. Input columns is also you can call. If I am taking the 4 inputs, for each input we will be having the respected coefficient. Respected coefficient will be having coefficients. Based on that, we will be predicting that, and we will be having one error value. One will be having beta naught, that is a constant value, and plus we will be having error value. So this, based on this, we will be predicting the y. Similar to that, we will be having here what? Weight and the input. So when you are using those values, normalization and standardization plays very important role, right? In order to build the better model, in that case, we have to do the normalization and standardization. What exactly is normalization and standardization? We have already seen. If you have x1, x2, x3, these are the features you are taking into the consideration. If this range is in between 0 to 5, and this range we have 10,000 to 20,000. If this range is equal to 20,000 to 50,000, and this range is equal to 0.1 to 0.9, in that case, huge difference will be having when it comes to scale of each and every feature. To make that scale free or to make unit free, in that case, what we will be doing? Standardization or normalization. Any one of those you can do. Whenever you are doing the standardization and normalization, it will be deciding factor for better accuracy of that particular model. For better accuracy of that particular model. So how, when it comes to artificial neural network, how it will be increasing the accuracy? We'll try to understand that. So in order to understand that, we need to go through back propagation. So there is one concept called back propagation. So what is it? Let's say I have input features. Input features I've taken, and this is my summation, and I have an activation function, and this is an output. And inputs are x1, x2, x3, something like that. I've taken x1, x2, x3, and x4 and x5. And we have always one bias. B0 will be having, and this is the output. And weights also will be having W1, W2, W3, W4, and W5. So whenever you are calculating the output, how will be calculating it? W1 x1 plus W2 x2 plus W3 x3 plus W4 x4 plus W5 x5 plus bias. So whatever the error that you are getting, so whatever the output that you are getting, will be comparing with actual. Will be comparing with the actual. If error is too much, in that case, what we'll be doing, that whatever the error that we are getting, we will be feeding that error back to the inputs. So this is how we will be changing the weights. So whatever the weights will be having previously, obviously it is not giving good result. In that case, what we'll be doing, whatever the output that we are getting, will feed back that output, so that we can modify those weights. Again, we will be checking for the error. Like that, each and every time, if we are feeding that output, whatever the output that we are getting, back to the inputs as a weights, in that case, we'll be calling it as back propagation. This process we are calling it as back propagation. And each and every time you are changing, right? Each and every time if you are changing, that case will be calling it as iterations. How many number of iterations you are doing? So this back propagation concept is crucial to understand how the accuracy of the model is keep changing. Let's say how it will be changing, whatever the new weights. So it is while doing the back propagation, let's say sigma activation function output. So whatever the output that you are getting, it is it will be back to the input weights. How it will be changing? This each and every time will be changing the weights of the input side. How it will be changing? Let's say new weight. This is the new weight, Wn plus 1 new weight. Old weight plus this is the learning rate. How much learning rate you want to have, that we will be deciding. And then error. So whatever the error will be having, it actual value and the predicted value, the difference will be getting back to that, and then input function will be having whatever the input feature you are considering, that input function. You can see here. So this is how we will be updating the weights each and every time. You can see here. This is the classification line, and we have these are the inputs, these data points. So you can see clear misclassification you have. So these are the blue class, and these are the red class. So misclassification we have done, right? So in that case, we will be getting the error. So what is that error starting? That will be giving the error, and then we will be changing those errors. Say learning rate is equal to 1.3, and the error that you are getting in the very first is equal to 0,1. If you want to have the new weights, in that case, new weights is equal to old weight plus learning rate is how much, and how much misclassification is done, and what is the input that you are doing. So what is that? 0, and plus what is the learning rate we'll be having? 1 by 3, and into what is the misclassification it is done? It is 0, and instead of 0 it is giving 1. In that case, we'll be considering that as, and what is the input value we'll be having? That is -1. So like that, we'll be calculating for W1x and W1y. So what are the error rates we'll be adding? The weights, new weights we'll be getting 1 by 3 and 1 by 4. Is it doing the classification again? Is it doing the good classification or misclassification? We don't have any misclassification. We have to check it. So still we have a misclassification, and in that case, what happens? Again, we will be changing the weights. So again, we'll be changing the weights. Whatever the weights, previous weights we'll be having, we'll do the back propagation. Again, we'll be calculating the weights. What is that? A new weight is equal to old weight plus learning rate. How much learning rate we have to give, that we will discuss in a minute. So learning rate and the misclassification, how much we got, and then inputs. So again, you got some inputs, some weights. That weights will be updating. So we can see here now, until and unless it is done, correct classification will keep good. Until and unless there is correct classification, it is keep good. So in order to understand one more thing, we need, each and every time you please upload, let's say 1,000 features will be having. So this is how we will be updating the weights. And until and unless there is correct classification and the accuracy that we are getting right, it is increased. Until and unless the accuracy is good, we will keep doing that back propagation. Once it is done, yeah, you can see this is the how the neuron will be. So we'll be having inputs. These are inputs and is the weights, inputs, weights, and we'll be having this the integration summation, and then we have activation function. Based on this summation, if this value is greater than 0, in that case, this activation function will be activated. If it is not, in that case, it won't be activated. It will become a 0. Activation function is a thresholding logic. So we'll be having this value, right? The summation value. Based on that only, it will be decided whether we have to activate that function or not. So this is a structure of a neuron. When you have just one output, in that case, we'll be using that. If it is having more, in that case, we'll be going with multilayer perceptron. Multilayer perceptron is a supplement of feed-forward network, and it consists of 3 types of layers, that is input layer, output layer, and hidden layer. So when you have just one input, one output, in that case, we can use single layer perceptron. But when you have multiple output, in that case, we will be going with multi-layer perceptron. In that, additionally, we will be having hidden layers. So all the processing, the input layer receives the input signal to be processed. All the input layers will be obviously receiving the inputs, and input layer to be processed. The required tasks such as prediction and classification is performed by the out layer. But most of the calculation, the classification and all those will be happening in output. But most of the process, the whole process, number of hidden layers that are placed in between the input and output layers are the true computational engine for MLP. So whole thing, the mathematical process, which feature we have to consider, on which base it is doing the classification and all these things will be happening in this hidden layers only. That is the reason what happens inside is, it is a black box. We don't have any idea what happens inside, what mathematical function it is doing, what kind of transformation it is doing. All these things are completely black box. We won't be having any idea. That is the reason this AI or multilayer perceptron or artificial neural network is not explainable. So these are the various activation functions we'll be having. Activation function decide whether a neuron should be activated or not. The kind of output that you're getting, what output you have to get, that is completely depends on the activation function, and it is activated by. So activation function decide whether neuron should be activated or not by calculating weight. If what is the weight? W1 x1 plus W2 weights into input will be having it. If the weighted sum is greater than required value, in that case, it will be activated. If it is not, in that case, it won't be activated. Like that, we'll be having various activation function. You can see here, step activation function will be having when you have 2 outputs, or in that case, we'll be using the step. And ramp activation function will be having. So binary classification for that, we can use this. You can see if function is greater than 0, in that case, it will be giving as 1. If it's otherwise, it is giving as 0. So when you have multiple outputs, in that case, you can go with the RAM function. So f is greater than 1, in that case, it is giving the 1 as an output. If it is in between 0 to 1, in that case, it is giving f. If it is less than, in that case, it is giving 0. And then we have a sigmoid. Sigmoid function also perform very better when it comes to binary classification. You will be having it. So we will be setting up range, and when it is for, one class, in that case it is, and there is one. So like that, when it comes to binary classification, it will be working really good when it comes to sigmoid function. So these are the various activation functions we'll be having. Like that, we have so many, whichever you want when it comes to multilayer perceptron, based on your requirement, whether you have to go with the sigmoid function or you want to go with some other function, which activation function if you want to use ReLU, leaky ReLU will be having, Maxwell will be having, various functions will be having, activation function will be having. Based on our requirement, we'll be choosing anyone. So like that, we'll be building the machine learning model. Before that, we will be having one called error surface. You have seen, right, that learning rate, how much value we have given. N is equal to neta. How much value we have to give? You shouldn't be giving too much and shouldn't be too less. We should maintain some optimum value so that we can get that local minima. So what exactly the local minima is? Let's say you have one 2 dimension. So let's say here I have this line. For this, what is the local minima? What is the global minima? What is the local maxima and what is the global maxima? We don't have anything like that. We have just one. There is local minima itself. It is a global minima. So in order to decrease the error rate that we are getting, for that we will be using the gradient descent algorithm. So what exactly we are doing? We will try to decrease the error rate by taking the local minima. If we are having the local minima, in that case, it is having the least error. In order to reach that, we have gradient descent algorithm. So here we have local minima, and we don't have anything such as like global minima or local minima. We have just one, that is the global minima itself. It is the local minima, and we have one maxima itself. It is a global maxima. It is a local maxima. But when you have multi-dimensional, so you can see here. So which one will you consider? Let's say when you are doing the algorithm came here. The input that you are taking, you have taken from here. In that process, what you will be doing, you will be trying to decrease the error rate. So when you are decreasing error rate, let's say it is here, from here you have taken that input, you are decreasing, here itself it is start, and if it is increasing, in that case it will stop at minimum only, and then it will be considered as global minimum. But is it the global minimum? If you are hitting the global minimum convergence, if you are hitting the global minimum, in that case we will be having the least error. So but it is not the global minimum. So what we have to do, multiple iterations we have to do. For that, we will be using the gradient descent algorithm to figure out where exactly we will be having the global minimum. So in order to decrease the error rate we'll be having in our data, in our model, we will be using the gradient descent algorithm. So you can see here, we will be decreasing. So how much learning rate we have to take? Let's say you have, let's say it is a complex multi-dimensional inputs we have taken. If you take learning rate is equal to high, let's say 2. In that case, it is like a bouncing a ball. If you drop a ball, so it is, we have here we have a minima, but it will be missing. When you are using the high neta value, that is a learning rate will be calling it as, and you will be missing that by mistake. If lucky, in that case you might be getting the global minima, but normally you won't be getting. If you are using the neta value is too less, in that case it will be taking so much time. Let's say like that we have taken. In order to reach that global minima, in that case it will be taking too much, and algorithm will get too slow. In that case, what you have to do, we have to give minimum value, optimum value like 0.3 in that case. So faster compared to the less, and we will be reaching that minimum. So this is how it will happen. So what we are trying to do, we have to keep that data value or the learning rate as it shouldn't be too less, it shouldn't be too much, so that we can reach that global minimum. So gradient descent is an iterative first order optimization each and every time, and I mean iterative means it is continuously happening until you get that minimum value or global minimum. First order optimization algorithm used to find local minima, maxima of the given function. In order to find out that, we'll be using this gradient descent algorithm. This method is commonly used in machine learning and deep learning to minimize cost function or loss function in a linear, especially when it comes to multiple linear regression or the linear regression based model. We'll be using this gradient descent algorithm. So once it is done, we'll see one use case scenario, guys. This is how artificial neural network or the multilayer perceptron will be working. We'll try to build one algorithm. That too, one banking use case we'll be having. We'll try to see how we can build the artificial neural network from the beginning. Modeling. So let me upload the data. So meanwhile, what exactly our objective? We'll try to understand. Let's say share modeling, copy at the path. Okay. Okay. So customer churn. So the problem statement is about customer churn. Customer churn means customer of bank. He is leaving. He is exiting your services. Maybe he is unsubscribing from your services. So based on the inputs, various features we'll be having, we'll try to predict who are the customers who can churn. What is the possibility that he can churn? If you know who's going to churn, in that case, you can come up with some customized offers. So if you know that particular person gonna churn, and if he is a valuable customer for you, in that case, what you can do, you can go with some customized loan interest rate, something like that. We can make so many business decisions. So it is important to do prediction whether who's gonna churn from your bank. Yeah. So what are the features I will be using for this? So in order to do this, first we have to import what are the necessary libraries we have to import. We'll look into this. So it is pandas first. In order to do the manipulation, in order to do the data manipulation or DataFrame manipulation, we need to have this pandas. And then what are the mathematical operations we'll be having to do that? I need to have that NumPy. And matplotlib I will be using for the visualization, Cbon I will be using, and OS, SciPy also I'm using scientific Python. And warnings, if you have any warnings, in that case I'm simply ignoring, and date time also I'm using. So these are the libraries that I require. So I'm importing upfront. So let me import that. And then I'm importing the data set. From using the pandas, I'm importing the data set. So these are the features I'll be having, guys. Row number, customer ID. So these features are not necessary, so you can simply drop it. It will comes under nominal data. What is the surname, credit score? It is important. Geography, gender, age, tenure, balance, number of products we'll be having, has card, credit card or not. So these are the one single individual's features. Customer ID, we have surname, credit score, how much credit score we have, geography, from where he belongs to, gender, age, tenure, how long he's been here with your bank, you can say, and balance, how much he has, number of products he has using, has credit card or not, is active a member or not, an estimated salary, how much salary he's having. When you know these kind of features, you can do a better decisions, right? So let's say, so these are the features we'll be having, and I'm doing the describe. Describe function, what it will do. And describe function, what it will be doing. So it will be finding out how many features will be having, how many entries you have, how many features you have, how many entries will be having, what are the minimum value, what is the maximum value, what is the mean value, and what is the standard deviation value, and what are the values that are present in 25 percentile, 50 percentile, 75 percentile. So all these details will be given by the describe function. What are the inferences that you can draw? You can say minimum value is how much, maximum value is how much. If it is having too much, the range of these values are too much. Let's say, what is the minimum value here? 1. And what is the maximum value we have? 10,000 we have. So it is a row number, so it doesn't matter. You can simply ignore this. And customer ID also, you don't need to consider that. We can simply ignore. And here you can see minimum value is how much? 350. That is the credit score. And what is the maximum we have? It is 850. So when it comes to age, what is the minimum value we have? It is 18. And maximum value what we have? 92. So it is fine. A tenure. So you can see the huge difference in between this. This range is different and this range is different. In that case, so it is, we need to do normalization. So because it is not having the same scale, we have to bring all the data. So whatever the data we have to bring down to single scale to make the data unit free or scale free, you can see. So we have to do the normalization or standardization based on whichever based on whatever the requirement you will be having. You can go with any one of those. So these are the inferences. I mean, these are the decisions that you can make, and how much data we have in 25 percentile, 50 percentile. What is the maximum data we'll be having? So all these things we will be getting using the describe function, and then I'll be looking into whether I have. Yes. Among these, do I have any null values or not? So if you want to look at data frame, how it is looking like, in that case, you can go with this. So data dot, right. So when you're using data dot head, in that case, what you'll be doing, first 5 inputs, the entries it will give you details about first 5 entries. So you can see here, row number, customer ID, surname, credit score, and geography, from where that particular person belongs to, gender, age, tenure, balance, how much he has, number of products, it is in dollars, maximum, number of products, has credit card or not, is active member or not. So these are the features we'll be having, and the description, if you do this kind of values will be good. And then I will be checking whether we have any null values or not in our data. So let me run it. Yeah, we don't have any null values in our data. So I'm finding the correlation between inputs and the output. So exited based on that. So these are the features we have, right? Using these features, we have to predict whether that particular person gonna exit or not. So customer churn it is. So if you know who's gonna exit, in that case, we can make so many business decisions. So correlation with respect to inputs and the output, you can see. Row number, it is not necessary, and the customer ID also, it is not necessary. Credit card, and their respected to whether you have credit card and credit score. I mean, this diagonal you will be getting just one, because it is a relation with respect to itself only. Credit score and the age, how much, we don't have much relationship, correlation at all. Credit score and the, where do you have any good correlation? we don't have any collinearity issue, guys. In that case, we can simply go, go with the model building. So if we have a great, collinearity issue, in that case, we have to remove those collinearity, which using the variable inflation factor, and there is other techniques also we'll be having, but we don't have any, so we can simply proceed with that. So I'm simply converting the list of columns, whatever the columns we'll be having, and what kind of data type we'll be having. If you have a, so here you can see what kind of data inputs we'll be having. Data, data type it is holding. See surname, so it is not necessary. We can simply drop this not an issue. Credit card, geography, gender we'll be considering, and I think we don't need to consider that as well. But if you want to, if you think it is important, you can consider balance, how much we have, number of products we'll be having. Spain, geography is important. So whatever the categorical value I'll be having, I'm simply converting using the label encoder. Import label encoder, and I'm invoking that label encoder function. And what I'm dropping here, I'm simply applying whichever the categorical values will be having. It will simply convert it into the label encoding. So now I have row number, customer number, surname. This doesn't give you any information. What I have to do, I have to simply drop those. So axis 1 I'm giving, that means axis 1. That means it is representing the column. If it is 0, in that case it is representing the rows. In place is equal to true, whatever the changes it is doing, it should update into the main data. So simply run it and run it. So we have removed row number, customer ID and surname, and we have done the label encoding as well. So we don't have any categorical values. You can see geography, previously we have categorical data. Now we have done the label encoding. So all the values are converted into this. Gender, we have 0, 0 and 1, just two will be having, male and female. And age, tenure, balance, number of products will be using, has credit card or not. 1, it is means that he has a credit card. If he doesn't have, in that case it is 0. Is active member, in that case yes, and it is not. So estimated salary, how much estimated salary will be having, whether he is going to exit it or not. So he is going to exit. If it is 0, he is not going to exit. So first, in order to build the model, first I'll be splitting the data, whatever the data I'll be having, into train and test. X is not defined. Think I missed something. Yeah, correlation we are looking into, and then we are simply converted the data into label. And here it is showing. Okay, so we are giving test size is equal to 0.5. In that case, whatever the train data, it will be automatically considering as 75, and test size it will be creating as 0.5. And then in order to build the machine learning model, what I'm giving here, output, I'm simply splitting the data into X and out, X and Y. So what is X will be having here? All the inputs. Inputs I'll be considering a drop when it comes to X what we have, other than the exited, whether that particular person exited or not. Exited is the target variable, right? So I'm simply dropping the target variable in that, and whatever the inputs will be having, I'm simply taking it to the X, and in Y will be having it other than exited. I'm simply dropping and I will be taking this exited. Target variable will be having exited, other than the exited, all will be taking into the input. So and then we'll be doing the scaling of the data. So since we have various data range, right? Various range we have seen. So when you have various range, in that case, it won't lead you to the good accuracy. What we have to do, we have to convert the whole data into single scalar to make the data scale free. For that, we'll be using the standard scalar. SQL pre-processing imports standard scalar. Whatever the inputs values I'll be having, I'm simply invoking that function, that is standard scalar. I'm simply given as input. And then once it is done, so I'm importing the keras and the sequential model. So whatever the things that we are doing, it is happens in a sequence. So I'll be sequential model I'm importing. It is model will be having dense. So in order to do all the operation, we need to have the dense, and in order to optimize, we need a dropout and batch normalization will be having. So I'm importing all these things that are required. So and I'm adding this dense layers, guys, adding the third hidden layer. So this we are not using any pre-trained model. Each and everything we are giving as an input. So when you are giving, and how many batches I'm giving? I'm giving 100. So each and epoch means iteration, number of iteration will be having. Here I'm giving the ReLU as activation function, and when it comes to compiling the model, I'm using the optimizer is equal to Adam, and loss I'll be using the binary cross entropy, and the metrics I'll be using the accuracy. So what it will happen when you run it? So each time 100 you have given, right? Each time one iteration will happen. Those will be calling it as epoch. Every time you can see loss will keep decreasing and the accuracy will be keep increasing. Every time the loss will be keep decreasing and accuracy will be increasing. Each and every epoch batch wise we are giving, and then finally you can see how much accuracy that you have ended up with. Loss is about 0.3608 and the accuracy we have about 84%. The same training loss and validation loss, training accuracy and testing accuracy I'm trying to plot, and here you can see most, training accuracy and the validation, training loss and validation loss, training accuracy or the testing accuracy pretty much same we will be having, almost equal only will be having. So yeah, whatever the model that you are doing, it is seems like it is a good model. Training accuracy and the testing accuracy are pretty much equal only. It is 84.48 will be having, and how much this are? Yeah, pretty much same only will be having. So whatever the model that you are building, it is okay. It is a good model only, but these are the not only features will be having. Various other features also we can consider when it comes to this model building to decide whether that particular person gonna default the loan or not. So like that, we will be coming up with the model, and when it comes to multiple layer perceptron and the single layer perceptron. So you can see the epoch size every time and how much inputs will be having. It will simply divide into 100 iterations or 100 epochs. And yeah, that's it, guys, about the artificial neural networks. And I hope you guys have an understanding regarding that what exactly the ANN, when we will be using multiple layer perceptron, when we will be using the single layer perceptron, when we will be using the machine learning model, when we will be using the artificial neural network. What is the difference between the machine learning model and artificial neural network? Why AI the artificial neural networks or multiple layer perceptron will be called as black box techniques and all those things. I hope you guys have an idea. So Yeah, thank you for joining, guys. And next class we'll be taking one more use case scenario, and we'll take one more, uh, you know, supervised learning. That is text mining. We'll try to cover, and text mining, how we will be applying the how we'll be doing the pre-processing, how we'll be coming up with the inferences, and what kind of analysis we can do using the text mining. All those things we'll try to understand in the next class. And I hope you will be joining in the next session as well. And yeah, thank you for joining for today's session, guys. And we'll see you in the next session. Until then, have a nice day.